Hello everyone, we are university students who are taking the course of Communication Principle and we are from Group 6. Today we are going to talk about how Internet of Things or IoT device communicate, and we will focus on important communication technique called DSBSC modulation, which stands for Double Sideband Suppressed Carrier. This topic may sound technical at first, but don't worry. By the end of this video, you will understand what DSBSC is and why it is used, and also why it is especially suitable for IoT devices, even if you do not have an engineering background. What is IoT and telemetry? Let's start with the basics. The Internet of Things IoT refers to devices connected to the Internet that collect and share data automatically. Examples of IoT devices include smart temperature sensor, fitness tracker, smart home system, and environmental monitoring devices. These devices often send data such as temperature, humidity, heat rate, or air quality. This process of sending sensor data from device to another system is called telemetry. In simple terms, IoT telemetry means sending sensor readings over a communication link so that the data can be monitored remotely without human intervention. Next, let's talk about the communication. Why communication needs modulation? The data produced by sensor is usually a low-frequency signal. The low-frequency signal cannot travel far, especially in wireless communication. To solve this problem, we use a process called modulation. Modulation converts the data signal into a form that is suitable for transmission, usually by combining it with a higher frequency signal called a carrier signal. This can allow the signal to travel longer distance through wireless channels such as air. Without modulation, IoT communication over long distance would not be possible. Now we move to the main topic, DSBSC modulation. DSBSC stands for Double Sideband Suppressed Carrier. In traditional amplitude modulation system, the transmitted signal contains one carrier signal, two sidebands which carry the actual information. However, the signal itself cannot carry any information, yet it consumes a large amount of transmission power. In DSBSC modulation, the carrier signal is completely removed or suppressed before transmission. Only the upper and lower sidebands, as shown in the figure here, which contain the information, are transmitted. This is why DSBSC is considered a more power-efficient modulation technique. Next, why DSBSC use less power? In full amplitude modulation system, a large portion of power is wasted transmitting the carrier signal, even though it carries no useful data. In the DSBSC, the carrier is not transmitted. All power transmitted is used for the sideband, and no power is wasted on unnecessary signals. As a result, the DSBSC use less power compared to the full amplitude modulation, and it make it become higher efficient. Next, why DSBSC is suitable for IoT devices? The power efficiency is very important for IoT device. Most IoT sensors are small, battery powered, and designed to operate for long periods without maintenance. By using DSBSC modulation, IoT device can save power, reduce wasted energy, and extend the battery life. This makes DSBSC a particular choice for IoT communication system, especially in remote and hard-to-reach locations. Next, let's understand the concept of channel. What is the communication channel? In a communication system, the channel is the medium through which the signal travels. This can include the A, which is wireless communication, cables, and also optical fiber. In IoT systems, wireless channels are commonly used, allowing devices to communicate without physical connection. Next, let's talk about the demodulation at the DSBSC. How the signal is recovered at the receiver during the demodulation. In the normal amplitude modulation system, we can use an envelope detector to recover the original message during the demodulation. This can work because the envelope of the signal follows the shape of the original data. However, in the DSBSC, the carrier is suppressed. Because of this, the envelope of the signal cannot represent the original signal, and the envelope detector cannot be used. Instead, DSBSC requires a synchronous or coherent detector, which uses a locally generated carrier that is synchronous with the transmitter carrier. This can allow the receiver to correctly recover the original message signal. Let's look at a real-life example. A smart temperature sensor continuously measures temperature, and it can send the data wirelessly to a server or a mobile application. To do this efficiently and with low power consumption, this sensor use modulation techniques such as DSBSC to transmit the data, and this can ensure the reliable communication, efficiency power usage, and the long device lifespan. In conclusion, IoT device on the communication system can send the sensor data using telemetry. Modulation also is necessary to make the signal suitable for transmission. The DSBSC modulation improves the power efficiency by suppressing the carrier signal. And this makes the DSBSC can suitable for battery power IoT device. Because the carrier is removed, the coherent detector is required at the receiver. Understanding this concept helps us to learn how modern IoT systems communicate efficiently in the real-world application. Thank you for watching, and please proceed to answer the Google Form provided after this video. The link of the Google Form is provided in the video description. Thank you.